factoring with negatives and fractions. Most people kind of got it for the most part. Now, one thing I didn't show you any with examples where there's fractions in the coefficients as well, and that is something that could happen. And you know, it's best to deal with it and to factor it out so that you don't have any fractions in the actual expression that you're dealing with. So, say you're given something like, I don't know. Okay, so say you said something like that and you were trying to factor it. Okay, now it's lagging a little bit, but it'll come up for sure. So here, the other one is, and if it's not, I'll just have to do it on the board. I don't know why it's been lagging so much lately. Something wrong. There it is. Okay, so so here we have two fractions that we're dealing with, not just one. We have 4/5 and 2/3, and they don't have the same denominator, so I made it a little harder right off the bat. If they have the same denominator, it's easier, because the first thing you would do here is to actually write both of those fractions as something with a common denominator, and you don't need to necessarily write out the entire expression over again. You could just kind of like write right above it, like convert it to have the same denominator, but you could write the whole thing out again. So if I'm looking at 4/5 and 2/3, what would be the common denominator there? 15. So instead of 4/5, how could I write that so it was over 15? 12/15. That's right. So this is just like, you know, like when you were younger and you had to do common denominators. And just leave everything else the same. Or like I said, if you wanted to, you don't have to necessarily write this out. You could just like kind of go like 12/15, like write it just in your own notes for yourself. That would be fine. Okay, I'm just writing it all out so that everybody can see the whole process. Oh, sorry. I should have done that one too. So 2/3, if I was putting it over 15, would be what? 10/15. So I just write it as 10/15 instead. Okay, now, instead of dealing with this, instead of just leaving those fractions in there, which would be fine technically, like it would still be correct, but if you can take them out and make that last inside bracket part as nice as possible, it's great. So here what I can take out is I can take out the largest common factor between 12/15 and 10/15. So here, if I took out 2/15, does that make sense to everybody? Because 2 is a common factor for 10 and 12, and 15 is a common factor for 15 and 15. If I did that, if I pull out 2/15 as well, you'll see what happens in a minute. If I take out 2/15, okay, then I look at the x and the y. So the x, I have a half and I have -3/2. Which of those two would I pull out front? The -3/2. So I pull out -3/2 because I just take out the lower one, right? Like always the lower one. And I have, with y's, I have -3 and I have 1. So I take out the lower of those two, which is -3. Okay. Now when I have and that looks terrible, right? That's really ugly looking. Now what's in my brackets there, okay, so I'm thinking, okay, 2/15. So this is where people start to freak out because they're like, I don't know what to do with fractions. But don't overcomplicate it. 2/15. What would I have to multiply 2/15 by to get 12/15? 6. Yeah, then you'd have, if you just multiply that by 6, you'd have 12 of them now. You had 2 times by 6, now you have 12. It makes sense, like, if you're just thinking of it logically. So I put a 6 there. How many x's will I have to put to go from -3/2 to 1/2? 2. 2 x's, or you can think of it as 4/2. Okay, 4/2 is because to go from -3/2 to 1/2, right? I had 1, I get to -2, add another one, -1, another one, get to 0, another one, I get to a half. Okay, it's like, think of it as half, like just instead of thinking of it as a fraction, imagine in your head that you're talking about something called halves, and you're going from -3 to 1. There's 4 numbers between -3 and 1, right? We all know like that, I assume. And now with y, there's already the y there. So what would I have to multiply 2/15 by to get 10/15? 5. So it's going to be plus 5. The x is already there, and I would need how many y's? 4. Because I have negative 3 on the outside, and I want to get to 1. Okay? So negative 3 and 4 together make 1. And so now the point of this is that this part here is very nice looking. Okay? That's why we did this. That part there is, hi boys, man, it's going to hurt when everybody else gets to exempt that exam. Okay? Doesn't matter to me. I'll only have to mark 2 of them, I think, so it'll be easy. Okay? So here we have a situation where the inside of the brackets looks nice and neat. Okay, now I also want to talk a little bit about simplifying from here. Okay? If you were simplifying this all the way, does anyone remember how you can deal with a negative exponent, like what that actually means? Like if I have, and I'll just kind of do an aside here, but if I had something like, I don't know, like let's say like x cubed y to the negative 2. The fact that that's negative 2, how could I write this without having to have that negative there? Is it? Well, not 1/2. No, it's not square root. 1/2 is the same as square root though, so that's good. Yes. Okay, so a negative exponent, what it really means is you can make that negative exponent positive by moving it from where it is to the denominator, or if it's already in the denominator, by moving it up to the numerator. So x cubed y to the negative 2 is equal to x cubed over y squared. Those are equal. Okay, that's something you learn in grade 10 as well, but you don't really do it much after that, so you've probably forgotten it. Okay. However, it's just a rule. Like if there's a negative exponent, you can get rid of that negative exponent by taking that factor and putting it on the bottom instead, putting it in the denominator. So these are equivalent. So here, where you have something like this, if I wanted to write this in a nicer way, which I would a lot of the time, what I can do is I can turn it into a fraction. I can put the positive stuff on top. So I can put the 6x squared, leave the 6x squared, and 5y to the 4 up here. Okay. The 2 is on the top because it's up top there. Then I could put the 15 on the bottom. I could put the x on the bottom and it makes it positive. And I could put the y on the bottom and it makes it positive. Okay, now, there's nothing in this that has a negative exponent. Okay, it's all like one big fraction together. It just looks a little neater. You don't see this like really nasty front stuff anymore because it's one big fraction. You don't have to do this. Like this is never like a requirement, but what you would end up seeing is this would be probably most people would call this simplified. They would say this is the simplified form. So if it was a multiple choice or something, the answer would often appear like that. So I would want you to be able to look at this and know that it's equivalent to this. Okay? To be able to see that they're equivalent. So all it is that the negatives move down to the bottom. That's negative. Negative exponents. You can't just move negative. I mean, I'm assuming you won't do that in grade 12, but I often have grade 10s who will just, like, if this was a negative 2, they just move it down to the bottom and be like, now it's positive 2. Can't do that. It's just if it's exponents. And anything that's already, like this 15 is in the denominator already, so it can go down to the denominator as well, and be in the denominator. Okay, that's just simplifying. Okay, so this process is just a way of making things look nicer, basically. Sometimes we'll end up with things canceling off and whatnot, and it's nice. So that's what we went over yesterday. I do want to review trinomials very briefly, like super briefly, just to remind everyone. So if you have something like yeah, this should work. Okay, so if you have something like this, okay, trinomial, and you have to factor it, what would you do first? Put the brackets, what?
Don't you like multiply the first and last?
You multiply the first and the last number, yep, you do that. So 2 times negative 5, which is negative 10. And that number represents what in our problem?
You have to multiply to get that number.
That's right. So you need to multiply to get negative 10. And the middle number is called our sum, and you have to add to it. All of you have seen this because you did it in grade 10 and 11. Okay? Whether or not right this second it feels familiar. There's an entire unit on it in grade 10. So you multiply the first times the last. That gives you your product, which is the number that you have to find. You have to find two numbers that multiply together to give you that product. So two numbers that multiply to give you negative 10. And then the middle number is your sum. So two numbers that add together to give you 3. So what are the two numbers that if I multiply them together give me negative 10? If I add them together give me 3? 5 and negative 2. Okay, 5 and negative 2 are the answers. So then from there, you aren't done. That's just the start. Okay, if you're in my class, you might have, different people do it differently. You either did decomposition or box method. Decomposition's the more commonly seen way, so that's the way I'll do it right now. If you use the box method when you first learned it, and you are continuing to use that, and you need a little refresher, ask me and I can go over it with you again. But decomposition is really not very hard. So decomposition looks like this. You take 2x squared, the first number, it just stays the same. Then you write the two middle numbers. So the 3x, instead of being 3x, it turns into 5x minus 2x. Those are obviously equivalent. Like 5 minus 2 is 3. So all I did is I wrote it out a little bit longer, and then the 5 stays there at the end. Okay, then what you do is you just put brackets around the first two and the last two. Okay, first two and the last two, and you pull out a common factor from each set of brackets. So from 2x squared and 5x, what is a common factor? X. Okay, so left over in the brackets then would be 2x plus 5. And from this set of brackets of negative 2x and negative 5, all I can take out is a negative 1, which also leaves me with 2x plus 5 now. And then there we go. And actually, this is kind of cool. Well, I don't know. We'll see. But I think it's kind of cool because it kind of has to do with what we were talking about yesterday. Up until now, at this point, like if I was teaching it to you, and I'm sure your other teachers do, they are like, and here we go, you have your factors. It's 2x minus 5 is one of them, because that's the one, or 2x plus 5, sorry, because that's the one that appears both times. That's one factor. And then x minus 1 is your other factor. And that's usually the way it kind of goes, and you just remember that. But the reason for it is what we talked about yesterday. Remember, like 2x plus 5 is actually a common factor between these two terms. They each have 2x plus 5. So I can pull that 2x plus 5 out front. And then I think about, I'm like, okay, well, what would I have to multiply 2x plus 5 by to get this? And the answer is just x. And then what would I have to multiply it by to get this? And the answer is just negative 1. Okay, which is why those end up being the factors. Okay, so this is sometimes called by grouping, factoring by grouping. Since everybody like in the world learns this when they turn about 14, there's like a billion YouTube tutorials on it. So if this is something you're struggling with, don't worry, you've done it. Like you had to do it to pass Math 10 and to pass Math 20. So you have done it whether or not you remember it. It'll just take a little bit of refreshing, maybe. So if you need to practice it a bit, let me know. I will give out, there will be a couple questions like this on your test. But you want to be really comfortable with this. If you don't have to do these steps, like I feel like I've taught a couple of you who didn't need to do these steps, who could just jump right from the beginning to the end, cool. I don't care how you get there. Like, I personally, when I factor, I would never do this. I would just look at it and think of the answer. Okay? And if that's how you want to do it, I'm totally fine with that. I'm not testing you on whether or not you know how to do decomposition. Okay? I just want you to be able to factor. So if you can look at something like this original question, and say, hey, okay, well, I know that the first two, this is what I do personally when I do it. I say, well, I know that the first two numbers have to multiply to 2. So I know it's going to be 2 and 1, because that's the only thing that multiplies to 2. And I know that the last two numbers are going to have to multiply to 5. So I know it's going to be 5 and 1. And And then I just look at it, and I'm like, oh, it's going to have to be plus 5 and minus 1, because that will give me 5x minus 2x, which is 3x. That's how I personally do this. I just look at it. This becomes a problem when the numbers are really, if they're higher. Like if the first number is 6x squared, then suddenly it's not so obvious that it's 6 and 1, because it could also be 3 and 2. That's when you have more possibilities. But if it's a number like 2 or 3 in the front, there's really no need to necessarily to do all the steps. But these steps do work 100% of the time. Okay, so that's trinomials. Okay. Similarly to trinomials, and that you've learned with trinomials, is what we call the difference of squares. It's everyone's favorite type of factoring because it's easy. Okay? So if you have something like x squared minus 25, what's that in factored form? And I know it's not up there yet, but it will be. Okay, x squared minus 25, what does that factor to? Great. X plus 5, x minus 5. Somebody, at least one person remembered. I'm sure more than one, and that's awesome. Okay, that's better than some is. Okay. So x plus 5 and x minus 5. It's that easy to factor difference of squares, right? It's like you just take the square root of them, you put 1 plus, 1 minus, it's lagging, but it'll be up there. So it's x plus 5, x minus 5. If I had something like 4x squared minus 9, my factors would be 2x plus 3, 2x minus 3. I can't quit out of this and enter back in. It's the thing on my computer that keeps the iPad going. Okay, so x squared minus 25. Yeah, so that's how difference of squares works. Now there is also a rule for difference of cubes and for sum of cubes. Yeah, I'm just going to go ahead and say you don't have to memorize it. Like, I'll just give it to you if you need it. Okay, so you don't need to memorize these rules. But there's 2 rules. Write them down right now, though, so that you have them, please. They're a cubed plus b cubed is equal to a plus b, a squared minus ab plus b squared, and a cubed minus b cubed is just a minus b, a squared plus ab plus b squared. Yeah, so like I would give you these equations, these formulas. It's like 1 or 2 questions kind of thing, like not like excessively. It would show up on this test, this unit test, but I would give you the formula to use so you don't need to have it memorized. I don't know, honestly, like if I think about like the AP test, I don't remember it showing up ever, but it could. I bet you in some of the older ones, actually, because they used to really be into factoring. I kind of feel like more so than they are now. So this is just a way to factor something if you have difference of cubes. It's important because sometimes you can factor this and then something cancels, which is nice. It's always nice when something cancels off. Let's just do one example of this so that you can kind of see how the formulas work. I do tend to see like, it looks like not that bad. If you have a formula, you'd think it would be easy, but sometimes it's not. So if you had something like, okay, I'll just do kind of a straight-ish forward one. Okay, 8x cubed minus 125. If I wanted to factor that, okay, this can factor because this is difference of cubes. So first of all, you'd have to recognize that it's difference of cubes. 8 is a cube, x cubed is a cubed, and 125 is a cube. Okay, they're all cubes, so we have a difference of cubes here. So we have to use this. Now the problem I see students have is they have trouble understanding what a and b are. If I was like doing this one, what would, like if a cubed minus b cubed is my general form, what's a in this situation? 2x, thank you. So it's not 8x, which is the problem that people have. Okay, people are always like, it's 8, because there's an 8 there. But a cubed means that all of a has been cubed. So 2x, if I cube 2x, I have to cube the 2, I get the 8. And I cube the x, it's the 3. So what would my b value be here? 5. And you don't need to worry with the negative 5 because the negative is already in the equation there. Okay, but it's okay, it's like fine to think of it that way. So then once you identify that, if you just take a minute and identify what A and B are, this does become like a significantly easier process. I don't know, people don't like to do it for some reason, but if you just do it, it becomes much easier, because then it becomes really obvious. Like A minus B then is 2x minus 5. A squared, what would A squared be? 4. Just 4? 4x squared. AB would be 2x times 5, which is what? 10x. Plus b squared, which would be 25. And there we go. That's how you do it. And it's factored. That trinomial that's in your brackets at the end, the trinomial, like the 4x squared plus 10x plus 25, I always have students who are like, and can I factor this? Like, and they're like trying to factor it. Like they're like first times last and like trying to do it. No, it can never be factored. Okay? It's like always just going to be this. So you're done. What ends up happening a lot is if this is like a fraction, like you have a rational expression and this is on the top, what ends up happening often is that this part can cancel. Okay, so you'll have like a fraction and then this would also be on the bottom, so you could cancel them off. Okay, that ends up happening. That tends to be the situation where difference of cubes is actually useful, is when you can do that. So this is I don't know, everyone write it down so that you have it in front of you when I give out the assignment, please. But it's pretty simple. It's not very hard, but you do need to, and I'll give it to you. I promise I'll give you the formula. So it's just, you have to just pick out what A and B are. Okay, and then our very last thing, I know it's been just a fun time here with factoring, but our very last part is factoring quartics and cubics. As I said, I'm not going to put this on the test, and I'm like thinking, I don't think I've ever seen it on the test. It will be on the assignment though. I want you to be able to do it because it's like a refresher. For those of you who are just taking Math 30 right now, you've never done it before, but as I said, it's really not that hard. It just takes a little bit of practice, and so I want you to practice it. And then if you're in Math 30-1, when you get to this in, I don't know, the next week, because you're going to be doing it really soon, you'll have seen it before, and it might be a little bit easier. Okay? Maybe I'm like really good at teaching it, I don't know. I doubt it, actually. Okay, but if you have a cubic function or expression, okay, like this one here, that is going to show up whenever it chooses to, there is a way to factor these, but it's kind of a long process, or longish, longer than you might like. First of all, it's using something called synthetic division. So, first of all, you have to figure out one factor that works, okay? And that factor, I'm just going to go ahead and say it's always going to be a factor of this number. So what are the factors of -6? Or of 6? 3, 1, those are excellent answers. 6 and 2. Okay, all of those are excellent answers. So 1, 2, 3, 6, and it can be positive or negative, 1, 2, 3, 6. So what you do to test this out and to find the one that actually works is you just plug them in. So you're like, you plug in 1, then you plug in -1, then you plug in 2, then you plug in -2. And does anyone who's taken Math 30 already remember how you can tell if it's a factor? What should you get if it is a factor? 0. Okay? Those are, if they're factors, it's because they are what we call zeros. Okay? So if it's a factor, it's a 0. So if we plug it in, it should give us 0. So if I plug in 1 to this, I get 1 plus 4 minus 5, or minus 6, sorry, which is not 0. So 1 does not work. Okay, so I try -1. If I plug -1 in, I get 4 minus 1. I thought I made this up so that 1 would work. Probably means I screwed it up. I hope one of these works. We'll see. Okay, if not, I'll have to start a new one. Yeah, so -1 doesn't work either. 2, 8. No, none of these are going to work. Dang it. Okay, I'll have to make up a different one. Oh, actually, you know what? I'll use the one from your on this assignment, whichever one I like, because then you'll have done it. You can just copy it.
Callie,
Yep.
what do you put the number in?
In for x. In for x. Yeah. Okay. So let's try it again. Hey, I'm just gonna